All right, let's dive into one of the most powerful and honestly essential concepts in Kubernetes, deployments. We're going to break down the art of handling application updates, safely without causing a panic. Let's get into it.
So, this is the big question, right? For anyone who manages software, this is a constant challenge. You've got your application, it's live, people are using it, and now you have to push a new feature or a bug fix. How in the world do you perform that kind of open-heart surgery on a running system without anyone even noticing?
Because if you try to do this manually, let's say just by juggling ReplicaSets yourself, well, you're basically walking a tightrope without a net. It is incredibly risky. You'd have to carefully scale down the old version, scale up the new one, and just pray that everything goes perfectly. One tiny mistake, and poof, the whole thing comes crashing down.
And that really brings us to our first section here, just how high stakes this whole update process really is.
You see, a replica set is fantastic at its job, and its one job is making sure a certain number of identical pods are running. It's a bouncer, focused purely on stability, but it doesn't know anything about change. It wasn't built for that delicate, complex dance of moving from version 1 to version 2. So if the replica set is the muscle, what's the brain? Well, that brings us to the hero of our story today, the Kubernetes deployment. A deployment is a higher-level object that basically sits on top of replica sets and tells them what to do. Think of it like a really smart manager or an orchestrator. You just declared the state you want, like, hey, I want 10 pods running my new version, and the deployment handles all the tricky steps to make that happen safely.
And this is a brilliant way to picture the hierarchy. The deployment is the architect. It draws up the final blueprint. The replica set, that's the contractor, who looks at the plans for one specific version and makes sure the right number of workers are on site. And of course, the pods are the workers actually doing the job. You, the developer, you only talk to the architect. You don't have to micromanage all the contractors.
Okay, so now that we have our manager, we need to give it a game plan. And a deployment gives us two main strategies for how to handle an update.
Let's look at them side by side. First, you've got recreate. This is the big bang approach. It kills all the old pods first, and only then does it start creating the new ones. The downside? Obvious. You get downtime. Then there's rolling update. And this one is the default for very good reason. It gradually, gracefully replaces old pods with new ones, making sure there's absolutely no interruption in service. Zero downtime.
So you might be asking, why would anyone ever choose downtime? And, well, there are a few very specific cases, usually involving older applications. If your app simply can't handle having two different versions running at the same time, or maybe you're making a huge database schema change that's not backward compatible, you might be forced into a recreate to avoid corrupting your data. But for pretty much every other situation, you're going to want a rolling update. So let's really dig into the art of the roll and see how we can fine-tune it. You see, a rolling update isn't just a single fixed process. Kubernetes gives you these two little dials you can turn. And with these dials, you can perfectly balance how fast you want the update to go versus how safe and available you need it to be. The first dial is maxSurge. This basically tells Kubernetes how many extra pods it's allowed to create during the update, above your target number. The default is 25%. This lets new pods come online and get ready before the old ones have to be terminated, which makes the whole transition way smoother. So to make that real, if your goal is 10 pods and you set maxSurge to 20%, Kubernetes can temporarily spin up 2 new pods, bringing your total to 12 for a short period. This speeds things up because your new capacity is ready to go before the old capacity is removed. Now, the second dial is maxUnavailable, and this one is your safety net. It sets the absolute maximum number of pods that are allowed to be offline at any point during the update. This guarantees your application always has a minimum capacity to serve users. So again, with our 10 pods, a maxUnavailable of 20% means you're telling Kubernetes, hey, don't you ever let me dip below 8 healthy pods. It won't terminate an old pod until a new one is up and ready to take its place, always respecting that floor you've set. But what happens if, despite all these controls, the new version is just bad? This is where deployments are pure magic. They come with the ultimate undo button. And the secret to this is so simple, it's brilliant. When you update a deployment, it doesn't just toss out the old replica set.
No, it keeps it around, but it scales it down to 0 pods. So that dormant replica set just sits there, like a perfect snapshot of your last good version, ready to be reactivated at a moment's notice. The process itself is just beautiful in its simplicity. An update creates a new v2 replica set and puts the old v1 set to sleep. Need to roll back? Kubernetes just flips the script. It wakes up the old v1 set and puts the new, faulty v2 set to sleep. It's really that easy.
And this is the command that makes it all happen. One simple, clean command. kubectl rollout undo, and you instantly snap back to your last known good configuration. It just takes all the panic out of a bad deployment.
But wait, it gets even better. Deployments don't just give you a manual undo button. They have an automatic safety net for when updates start to go wrong right out of the gate.
So let's picture the classic developer nightmare. You push out your new version, v2, but there's a critical bug in it. The new pods start up, but they immediately crash. Or they just keep failing their health checks. They never get to a ready state where they can actually serve traffic.
Well, the deployment controller is always watching. It sees these new pods are failing, and because they aren't becoming ready, it knows it can't terminate any more of the old, stable pods without breaking that maxUnavailable rule. So what does it do? It automatically hits the brakes, it pauses the entire rollout. And this is the payoff. The update is frozen, the few broken v2 pods that got created are just sitting there, not getting any traffic, and most importantly, your users are completely safe. They're still being served by the stable, working v1 pods. A potential disaster was just quietly and automatically contained.
So, I'll leave you with this final thought. When you know you have this incredibly robust, automated safety net, a system that truly has your back, how does that change your entire philosophy on shipping code? Does it empower your team to release smaller changes more often? Does it make you braver? It's a powerful idea that goes way beyond just operations and can change the whole rhythm of how you develop software.